Go.
3, 2, 1, go.
Science shotgun.
Wait, what are the different types of friction?
Sliding friction is when an object is moving along a surface and is only sliding and is encountering friction with the surface the object is sliding on. For example, a book sliding across a table. The book is encountering friction with the table because it is sliding on it. As you can see, the laser is moving because we are sliding the object across the floor since the sliding friction is not enough to stop the object from moving. In this experiment with the laser, it was moving at a constant rate because the force that was applied to the object was larger than the sliding friction acting on the object. Although the object slid easily across the floor, it was still encountering some sliding friction.
Static friction is when there is a force on an object, but the friction is equal to or greater to the force, causing no movement. For example, when you try to push a refrigerator and it doesn't move, it is encountering static friction. In this example, there is no movement of the laser when we try to exert a force on this table. Static friction is what holds this table in place. In both these scenarios, static friction played a role because the force exerted was not great enough to put the object in motion.
Rolling friction is when an object is moving on a surface with a spinning motion and encountering friction this way. For example, when a bike is riding across the road, it is encountering rolling friction because the wheels are rolling on the surface. As you can see, the laser is moving in a circular motion because it is attached to a wheel that is encountering rolling friction with the surface. The laser showed rolling friction because the rolling motion of the wheel on the surface slows down the object's motion.
Fluid friction is when an object encounters air resistance or water resistance while in motion. For example, when a pitcher pitches a baseball, it is encountering air resistance while in the air before reaching the catcher's mitt. As you can see, the laser is going downward and has air resistance as it is going downward. The object is encountering air resistance, which makes the descent of the object with the laser slower.
Wait, what are the opposite of balance forces?
Balance forces are when there is no acceleration. The forces are equal, so there is no acceleration. For example, if a skydiver is flying through the air at a constant velocity, then the forces are balanced since he will not be accelerating. This means that the forces will be balanced because the forces are equal to each other. In this example with the arm wrestle, there is no movement or acceleration since the forces are balanced. This is due to the fact that I am exerting the same amount of force that Kyle is. So that means that forces are equal and there cannot be any acceleration or movement.
Unbalanced forces are when an object is accelerating. It is when a force is greater than the other, causing acceleration in that direction. For example, when a car begins to accelerate from a stop sign, the forces the wheels are applying is greater than the friction causing it to accelerate. In this example, the arm wrestle shows unbalanced forces because Coy is exerting a greater force than what Luke is exerting. This causes Coy to come back and win with acceleration.
Wait, what is net force?
Net force is the overall amount of forces that are acting on an object. For example, if a skydiver is falling downwards at 20 newtons and his parachute is pulling him up at 10 newtons, that means that he is falling at 10 newtons downward. In this example, we are showing the amount of net force that Coy and Luke have using an exercise ball. In this experiment, Luke has friction at 10 newtons and Coy is the applied force at 10 newtons. Because all the amount of net force equals each other, there is no movement and they just stop.
In this example, Luke is friction at 5 newtons and Coy is the applied force at 10 newtons. Coy's applied force overtakes Luke's friction and sends them in the direction Coy was moving at 5 newtons. In this example, Luke is friction at 0 newtons and Coy is the applied force at 10 newtons. Coy's applied force is greater than Luke's friction because there is no friction since Luke was standing there. Therefore, he applied 10 newtons.
Wait, what are free body diagrams?
A free body diagram is a diagram that explains and shows different types of motion. For example, we have a 3D model of a free body diagram that has applied, friction, norm, and gravity. In this example, I'm holding a free body diagram and Coy is pushing me based on what is happening on the free body diagram.
Wait, I thought that I was doing this part.
Coy, no.
In this example, I'm the applied force that is pushing Luke in the free body diagram because the arrow corresponds to how I'm pushing Luke. At first, when I'm pushing Luke, there's no friction, but when I keep pushing, the friction gets stronger and Luke stops, and then I stop pushing.
Go. Science shotgun! Let's go! Yeah! Number 2!